All right. So homework one. So I added some more explicit directions. So let me just run through these really quickly. One time only, you need to create an account on GitLab, right? That's fairly self-explanatory at this point. You got to do that once. And then one time per project. So these next steps are per project. So you're going to start working on homework 1, programming assignment 1, homework 17, whatever, right? On your Linux server, your laptop, wherever you're doing your work, make a directory with the name of your project so that you can keep all your files in one directory. Go into that directory using cd. So make the directory with makedir, cd into that directory, and say git init. Initialize a git repository in that directory. And then, still a one-time step, do the git remote add instruction, add origin, gitlab.com, your username / and whatever you plan to call this repository on GitLab. It doesn't have to be the same name as your directory, but it's less confusing if it is. So if you're making PA1, make a directory called PA1, git remote add origin, blah, 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 PA1.git. Okay, and that's going to link your local repository to your repository on GitLab. Don't go into GitLab first and create PA1 or homework 1 or something like that, because then it's going to complain, right? Start from Linux, make your local repository on the Linux server, and then use git remote add origin to clone it onto GitLab itself. And that's one time per project. And then, as you're developing your project, you do the usual thing. You create your files, you edit your files. When you're ready to add them to Git, you do git add, you do git commit. And then when you want to push them over, you do git push origin master. So it's that triple of steps, right? Git add, git commit, git push origin master. And then sometime before the deadline of the project, you need to add me as a reporter to the project, and that you do from GitLab. And there's instructions on the how-to for that. But this sort of breaks down the particular steps that you'll most likely be doing each time that you start a project. Does that make sense? And the way it was written originally in homework 1 was not necessarily ordered, so hopefully this is clearer. But that's the only thing I changed on this homework was the instructions. All right, let's do some shell programming. So first thing we want to talk about is variables. Okay, just like any other programming language, we can have variables in Bash. And it kind of looks exactly like how you would expect. Let's just set I equal to 10. Okay, I've created a variable named I. I've given it a value of 10. You don't have to declare variables in Bash. You don't say integer I, for example. If you say something equals something, it's going to assume that first something is a variable, and it'll give it the value of the second. And there's an echo statement, which, you know, if you say echo hello, it says hello. If you echo say what is this, it says what is this. It just repeats whatever is on the command line argument. And so if I echo I, what's it going to say? It's going to say I, because I told it to say I. But if I want the value of I, put a $sign in front. And when you say echo $I, it says don't show me I, don't show me $sign I, show me the value of this variable I. And so that's how I get back to my 10. So that's the first piece, thank you, of using variables. Assign a value by saying variable equals value, and you can get the value by saying $sign, name of the variable. And I can say name equals Nick, and if I echo $sign name, it's equal to Nick. Okay, everything in Bash is case sensitive. So if I say echo $sign name with an uppercase N, that has no value, so it just shows me a blank line. If I echo $sign uppercase I, that's different. I could set uppercase I equal to 99, that's a different variable. right? Lowercase I is 10, and uppercase I is 99. So case sensitive. Pretty much everything today is case sensitive. If I say name equals Nick Macias, it gets unhappy. So spaces are really critical in Bash. Way more critical than you're going to believe. Okay? C, spaces don't matter. You can put a million spaces in between your equal sign and your variable and stuff like that. It doesn't care. C, spacing is really, Bash spacing is really critical. So name equals Nick space Macias. That space is the end of the assignment statement. It's saying set name equal to Nick, and then it's saying Macias, and you know, it doesn't know what that is. It thinks it's a command. So if I wanted my value of name to have a space inside, there's a way we can do that. We could say name equals, and inside double quotes we can say whatever we want. And now if I echo $name, it's got the full string with the space inside. So we use double quotes to say this whole thing is a single string. It's a single something. And so name equals this one single something, which happens to have spaces. Alright, so we got variables, we got $sign for the value of a variable, we've got an echo statement for doing output basically. And we can do things like this. Echo, your name is $name, isn't it? And even though that $sign is inside the quotation marks, it will still treat $name as the value of that variable. So this will say, your name is Nick Macias, isn't it? So if you want to print out the value of I in C, it's printf. The value of I is %d\n unquote comma I, all of that nonsense. Here it's just the value of I is $I, 10. So this is another thing about Bash. It's really rapid prototyping. Right? You want to do something quick and dirty, throw together a Bash script. A whole lot quicker and a whole lot more powerful than C. But there's a price. It's going to be slower, but we're not going to notice for the most part unless we're, you know, mining bitcoins or doing something intensive. And the syntax is going to be pickier, but we're going to learn the syntax, so not big downsides. Okay, the other thing we want to do is input. We want the user to be able to type something in, and we want to take what they type and put it into a variable. And the command for that is read. So we can say something like read password. And now the shell is sitting here and it's waiting for me to type something in. And I can type, haha, this is my password. And now if I look at the value of this variable password, it's got whatever I typed in. So we've got a good start on a programming language. Right, variables, we can assign them with an equal sign. We can read their value with a $sign. We can do an echo statement for output. We can do a read statement for input. And we're doing these on the command line right now, but we can also do these inside a shell script. So let's make a script. I'll call it S1. So what's the first line of our script got to be?
The bash bin thing?
Yeah, the bash bin thing. So number exclamation bin bash. And I'm going to put some comments in here. So we're going to want to be in the habit of commenting our code. Okay, as we go through, commenting is going to count more and more of a percentage of your grade. So we want to start getting into some commenting habits, which I'll usually skip up here, but that's a bad example. Script 1, sample code for doing bashy things inside a file or a script. Alright, so there's a simple 4-line script. It says hello, it says enter your name, it says read name, which will ask you to type something in, and whatever you type will be assigned to the value of this variable called name, and then it'll say hello to you by name. Alright, so how do we run our script? Change the protection, good. So change mode 755 S1, and then we just type the name of the script, S1. Hello, welcome to my script, enter my name. So what is my name? Bugs Bunny. Hello, Bugs Bunny. Pretty straightforward, right? So questions so far?
I think last time I tried to do it when I did like backspace N, it didn't like to do the new line. Does it do new line in bash?
So yes and no. Right, if I do echo hello \n there \n by \n, it shows me exactly what I typed in. It's extremely literal. There's a switch you can use on echo that will tell it to actually do those things. So -E says enable interpretation of / sequences. So if I say echo -E, now it's working like the way that printf would work. And so what I did was the manual command, man echo, which shows me information about the echo instruction. And there's not a whole lot to echo. There's a -E, which we just discovered. There's also this other switch -N, which says do not output the trailing new line. And that's kind of useful, because I can say echo -N what's up, and it says what's up, but it did not print a new line at the end. It just went straight on to my next prompt, 2007. And that can be a nice nicety. For example, when I say enter your name, I could say echo -N enter your name. And now when I run this, it says enter your name, and I'm still sitting there with my blinking cursor at the end of that prompt. Right? So there's the backslashes that we know from C. Oh, it doesn't list all of the options. So there's also a -S switch, which is the secret switch. So it says read -S name. And I can type, but it won't show you on the screen what the person's typing. But I did type stuff in. Alright, so you can use that as a secret option. I can say read -T. I think I've got the switch right. T5 is asking me for my name. It'll give up after 5 seconds. So you can put a time limit on how long the person has to enter. and let's see, n. And you can say read dash n followed by a number, and it will only let the person type that many letters, that many characters. So read dash n1 says you're only allowed to type one letter. As soon as you've typed a letter, this command's going to exit. So if I try to type my name as Nick, I type the N and I'm done. And if I look at the value of name, it's just that one letter. So if you want someone to enter like a quick response like Y or N, and you don't want them to have to hit the enter at the end, you can say read dash N1. As soon as they hit a Y or an N or any other letter, your script will continue. So saying man, I switched from echo to read. Anyway, if you look at the man page, anyway, I switched things up on you. All right, so you can echo to do output, you can read to do input, right? Okay, so the next thing we want to do is we want to manipulate variables. In particular, we want to be able to do arithmetic on things like numbers. So I can say x equals 10, echo $x is 10, echo $x plus 1 is 10 plus 1. Why? Because echo is very literal. I said echo the value of x, followed by a plus sign, followed by a 1. That's what it gave me. So what if we really, really want to add 1 to the value of x if we were to treat x as a number? So there's a peculiar syntax for this. Echo $, parentheses, parentheses, and then we can put an arithmetic expression inside there. And this will say treat x as the value of a variable, find its value, add 1 to it. That's what the result of that $, paren will be. There's your 11. So $, paren expression, arithmetic expression, actually evaluates it. Alright, so echo $x plus $x just shows me 10 plus 10. Echo $, parentheses, parentheses, x plus x, that gets you to 20. So you have enough for ODP 403 now. Okay, this is more than enough to do what we need to do in the next ODP. So let's make a script that kind of does something like what the ODP will do, and then we'll look at the ODP itself. I'm going to get rid of my comments. So enter a number. And let's read this number and let's just call it n. And let's just say 2 times whatever the value of n is, and let's print out actually the value of 2 times n. So enter a number, we'll do 13. 2 times 13 is 26. Alright, not hugely profound, but if you can do all of the things that we've just done, right, you're through more than enough to do the ODP, and you're through a lot of what we're going to have to do with everything we do in shell scripting, including the first programming assignment.
So when we write to code in like C, we end it with .c, .get. Is there a syntax that we should use for that?
So sometimes people use .sh for the end of a shell script. Sometimes they just leave it with just a file name with nothing after the dot. to some degree, it really doesn't matter. It's mostly convention. But if you call the shell script .c or .h, it would be confusing to people. So I wouldn't do that. I would say either leave it with just the name of the file without an extension, or .sh. I haven't really seen people do .bash, but you could do that, right, if that made sense to you. So sort of dealer's choice.
And then one more. How come we don't have to do period slash to run an execute?
Ah, okay,
Just
yeah.
to the server?
So this goes into paths, into variables too. So on CTEC server, you have to say ./s1. And what is that doing? Well, if you say S1, that's what's called a relative file name. It's saying look for S1 in my current directory, right? If you say ./s1, you're explicitly saying what the name of the file is that you want to run. Dot means my current directory, right? /s1 means S1 in my current directory. If you say /bin/ls, it runs the ls command that's found in /bin. Okay, but if you just type in something like S1 or ls or gcc, it doesn't know where that file might be. Right, it's looking for a program that it can run. Where is it going to look for that? Well, there's a variable in bash called path. And if you look at the value of path, it's a colon-separated list of directories. And anytime you type in a command, if it doesn't happen to know what that command is supposed to do, if it's not a built-in command, it'll start looking through all these directories. And as soon as it finds something with that name, that's the program it'll execute. So when we say ls, eventually it gets down to where it looks in the /bin directory, and it finds /bin/ls and it runs it. Okay, so the very first thing in our path is a period. That's the abbreviation for our current directory. So any command you type, the first thing it's going to do is see if your current directory has a file with that name, and if it does, it'll run it. Now, if you go to the CTEC server and you look at your path, you won't see that .: in there. Okay, the default path on that machine does not include your current directory. So if you say S1, it doesn't find it in any of these directories. It says, I don't know what that command is. So you have to explicitly say period/S1 to say S1 in this current directory. So I set up a system-wide path. You just put dot in the beginning of it. So you can still say /, but you're not required to. So there's your default path on CTEC. And it's a variable. And on my system, I set my path to look like this, explicitly for various reasons. And then I actually change it to look like that.
So I just noticed you wanted to bash RC. So like my aliases go away every time I exit the terminal.
Yeah, so I should pay you because you're like pacing my lecture beautifully here. So when you set up a variable name, whether it's X or name or path, right, that's temporary. When you exit, it goes away. When you set up an alias, right, alias, my command name equals some other command, that goes away when you log out. But every time that you log in, there's a file in your home directory called .bashrc that gets executed. It's a shell script. And it gets executed every time you log in. So inside here, you can do things like create aliases, right? And they'll get executed every time you start a new session. So that's where you put up things that you want to have persist from one instance to the next. So my violin command and my music tools command and all that kind of stuff are always available for me. So I was looking on my laptop when we were looking at path. The actual path that you'll see if you echo $path will probably be this, with colon dot at the very end. And the nick/QA is peculiar to my login. But I think the system-wide path is all of those things with a dot at the end. So it looks in these other directories for command first, and if it doesn't find it there, then it'll look in your local directory. All right, other questions? We can do arithmetic. So you need three things for a programming language to be what we call Turing complete, able to write any program basically. You need to be able to do sequential statements. Okay, we can do that. You need to be able to do conditional statements. If this, do one thing, otherwise do a different thing. And you need to be able to do loops. For loops, while loops. If you have those three things, you've got a full programming language. So we've got one of those pieces, sequential statements, including variables and assignments, input, output, arithmetic, that kind of stuff. We still need to do looping and we need to do conditionals, but not for ODP 403. So let's take a look at ODP 403. Alright, so 403, you're writing another script, so still not a C program. We're doing scripts for the next few ODPs. You're going to write a script that reads one line of input, treats that input as an integer, and then prints out 2 times that integer. Kind of like something we just did a minute ago. So if your script's named ODP 403 and you type a 12, it should print out 24. And it's really important that it only prints out one thing, which is the value of 2 times the number that you put in. If you print out the answer is 2 times that, you'll get 0 out of 10. Okay, because it's being graded by an automated tool, remember, not by me. So really important, you read a number, prints out 2 times that number, and you're done. If your program prints out, please enter a number, it'll grade as 0 out of 10. Okay, so these first few ODPs where we're writing scripts, you got to be really, really, really close to the specification. If you deviate just a little bit, it'll probably take you from a 10 out of 10 down to a 0. So run your script, read an integer, print out twice that integer, and you're done. And I can show you what it should look like. So when you run your program, here's what should happen. Nothing. It sits there and blinks at you. You type in a number, it prints out twice that number, and it exits. Okay, if that's what your program does, you should be able to assess it and get 10 out of 10. Let's assess it. 10 out of 10. It's got 3 different tested runs. So you want 10 out of 10 on each of them. Alright, questions on the ODP? Yeah?
Do we need to worry about like decimal numbers or anything like that?
I probably should have specified that, but no, you can assume that we're dealing with integers. Interprets the input as an integer. So yeah, you can assume that the input's going to be an integer. Okay, so for this one, you don't need to worry about error checking. All the test cases will have a valid integer. So don't worry what happens if they type in ha-ha instead of a number. It's not going to happen. Okay. Some of the other ODPs down the road, we need to start dealing with that. Alright, so everybody able to do ODP 403? Cool. All right. Well, let's keep going. So on Canvas, in that top area, there's a section called If, While, For, Etc. in Bash. This is a cheat sheet. Okay, this is a synopsis of what we're going to be talking about for the next few days, which is how you do different kinds of conditionals and loops in Bash. And I'm going to skip for loops for now. I'm going to go straight to while loops. A while loop is pretty straightforward. While space, bracket, bracket, space, condition, space, bracket, bracket, do, bunch of stuff you want to do, and then done. Okay, the spaces are really important. So let's say let's actually make a script. So I equals 0, I'm going to use that as our loop counter. Remember, if you have a number sign, that's a comment. So shell doesn't care what I type after that. So while space, bracket, bracket, space, then I'm going to type some condition. Okay, conditions. I'm looking for an integer comparison. I want to basically loop until I is equal to 10. Okay, integer comparisons, you have to use one of these things: dash EQ for equal, dash NE for not equal, greater than, less than, and so on and so forth. And so you're going to see things like this: while $x dash EQ $y, or 7 dash GT $some variable, and so on. So let's write a loop that says let's loop as long as I is less than 10. So while bracket bracket $I less than 10, close bracket bracket. And then we say do, and we can say hello, and let's add 1 to the value of I, and let's say done.
We're supposed to be saying done at the end of all times.
Done is at the end of the while loop.
Oh.
So it's while condition do, bunch of statements, and then the keyword done. Alright, so that's part of the while loop basically. So do is like the opening curly bracket in C, and done is like the closing curly bracket. So let's do that, run that, and it prints out hello, and I'm guessing that's 10 times. That's 10 times. All right, spacing. X equals 10, echo $x, that's fine. X space equals space 10, command not found. X space equals 10, command not found. X equals space 10, 10, command not found. Okay, super picky. And when I started using Bash, which was years after doing like a lot of C and stuff like that, this was really frustrating to me. But you kind of have to accept that like this is how Bash is. And once you accept that and you say, okay, I'm going to work with Bash as it is, then it's not so bad. But just super picky. So same thing up here. If you leave off these spaces, if you say while space bracket bracket $I, well, let's just do that. Right, and I try to run it, bracket bracket 0, command not found, whatever that means. So come back to this cheat sheet, right, and this should steer you in the right direction. And we're just doing numbers for now. Okay, now I could have also done while 10 is greater than $i. Alright, and that'll work just fine, because that's the same thing. If 10 is greater than I, then I is less than 10. And I can add extra spaces here. If it needs a space, you can usually put in extra spaces. You just can't leave them out, and you can't add a space if it doesn't want at least one space. So this is all we need for tomorrow's ODP, ODP 404, which will be due Saturday morning, Friday night. So we're ahead of the game anyway. But that's a basic while loop. We don't need for loops, right? You can do a for loop if you have a while statement. We've done a for loop. We just did for I equals 0 to 10 or to 9. So while loops are probably the more important thing to figure out. And you know, sometimes, actually almost every time that I write a while loop, I forget that I equals I plus 1 at the bottom of the loop. And I do something like this. What's going to happen if I run this? Yeah, it's just going to run forever because I is equal to 0. It's never going to change. It's always going to be less than 10. And so if I run this, it's just going to start, you know, yelling at me. Hello. So do you remember how to get out of that? Control C, right? Hold down Control, hit C. And that's important. Right, Control C gets you out of a loop. Don't do Control Z. If you go online, you say, how do I stop a process? Half the answers you find will say use Control Z. And you know, if you do this and you hit Control Z, hey, it stopped it, okay? But it's done other things too that will get you in trouble eventually. Because it hasn't killed my job. My job is still out there. And if I do this too many times, I'm going to run out of resources. It's not going to let me run any commands. And then you're on Discord trying to figure out what happened. So if you happen to do this, you can say FG, and it'll start running it again, and then do a Control C. So Control Z, stop. It says stop, but it's actually a pause. And then FG says resume. But your best action, don't do that. Control C says stop your process. Or just never make a mistake. Because that works. All right. So this cheat sheet will tell you how to do. Let me make this full screen, fuller screen. This will tell you how to do for loops. It will tell you how to do while loops. It will tell you how to compare strings. So if we want to know if this variable is equal to this particular set of characters, right? That's different from knowing if the value of this integer is equal to the value of that integer. If we're doing strings that we're comparing, we compare by using equals equals, just like we do in C, or number sign equals for not equal. If we're comparing integer values, we have to use these kind of old school -EQ, -NE, and so on. All right, so this is really, really important, what I'm about to say. Sometimes you might use equal equal to compare integers, and it works anyway. Okay? A lot of times you'll use equal equal to compare integers, which you shouldn't do, and it will work when you're testing it, and then when I test it, it won't work. Okay? Because I make test cases that test lots of different things, including things like that. So writing your code and having it work is usually a pretty good indicator that your code is correct. But only if you do every possible test case that someone could possibly throw at it. And with Bash in particular, there's a lot of ways that you might write a script that will look like it'll work. And maybe it'll work 9 times out of 10, but it's still not right. And the only way to avoid that is stick to this template. Okay? If you stick to this template, your code will work. If you're comparing integers, make sure you're using these things. If you're comparing strings, make sure you're using these things. The equal, the exclamation mark equal. If you're doing a while loop, do while space, bracket, bracket, space, your condition, space, bracket, bracket, closing. Sometimes you can use 1 bracket instead of 2 and it'll work, and sometimes it won't. Sometimes you can use parentheses and that will work, and sometimes that won't. So I'm going to make a requirement here, and I've debated this a lot over the summer. I'm going to make a requirement. When you're writing code for this class in Bash and you're writing a while loop, it's got to be that style of a while statement. While space, bracket, bracket, space, condition, space, bracket, bracket. Do statements done. When you're writing an if statement, it's got to be if space, bracket, bracket, space, condition, space, bracket, bracket. Then things that you want to do, and then instead of done at the end of an if, we say fi for fee. And I'm going to insist that that's the version of an if statement that you use. And if you happen to be somebody who's been doing Bash a bunch and you already know how to use Bash and so on, I apologize. Okay, and this would have annoyed me when I was a student, because it's like, I know how to write if statements, you don't have to tell me to do it this way, right? But I'm going to have to ask you to do it this way, because the problem is I get assignments turned in and they work in the particular case that I asked about. This happens on exams mainly. You know, write a script that'll do this. And based on the assignment specification, they could have gotten away with 1 bracket, right? But in general, that wouldn't have worked. So there's 2 possibilities. The student is very, very clever and knew that the 1 bracket would work in this case because of something I said in the problem, or the student is very, very lucky and used 1 bracket because that's how they thought they wrote if statements, right? So we're going to have to stick to this template. All right, and we'll play with conditionals tomorrow. We don't have to get into those today. But looping, so while, do, statements, done. And there's other ways that you can do this, and if you write a while loop, all right, so here's a while loop I'm writing at the command line, and you can do this in Bash. You don't even need to write a script. So I set I equal to 0, and then I said, while I is less than 5, do echo $i equals I plus 1, and done. And as soon as I hit enter, it will actually execute this while loop. And you notice my prompt change, it didn't prompt 2048, it's prompting with this greater than sign. That means I'm in the middle of basically 1 statement. And so when I say done, it goes ahead and it runs my loop. Now, if I go back to that last command using the up arrow, it looks like this. It's all sitting there on 1 line with semicolons in between them. Okay? I'm going to say don't use the semicolons. All right? And that's simply because more often than not, you use the semicolons and you don't get them in the right spot. And I'm never going to write a statement like that, and you're not going to see that in that cheat sheet. Okay? While, do, statements, done. Okay? All right, questions about any of this, looping variables, stuff? And the next ODP that we'll talk about tomorrow is just going to be a script that has some looping in it. So the ODP should be starting to get more straightforward, right? The first 1 or 2 were from wherever you happen to be to some level, but now they should be more incremental from day to day. So that's good news. All right, I'll let you out a minute and a half early. I will see you tomorrow.